Okay, I'm going to go over how you can test your generator or motor to see if it's doesn't have a short circuit in it, or and if it can be operational. There are two sets of coils that you want to make sure are not broken or short circuiting, and that's the coils that are in the rotor and the coils that are in the stator. The coils you do not want to be connected to each other. Like, you don't want one of these coils to be connected to one of these other coils here. You want them to be isolated from each other, and you want them isolated from the chassis or the frame of the generator. And the way you figure that out is you have a voltmeter and you put it on resistance, and right now I have it connected to the stator coils for the output right now, and it's showing resistance. So that means that the stator coils are not broken, they're still intact. And if I keep one of the voltmeter cables connected to the coil, and then take the other one and connect it to the frame, like anywhere where there's some bare metal for the frame, like this is painted, but yeah, it's probably like maybe in this hole or something like that where there's no paint. You want to touch the bare metal of the chassis, and you won't want to see any resistance on your voltmeter from the coils to the chassis or from the commutator to the chassis. So I put that in there where there's no paint, and touch this, and there's no resistance from the commutator to the chassis or from the stator coils to the chassis. So there's no short circuit between the coils in the rotor or the stator to the chassis, so that's good. And we already checked the resistance of the stator coils, and they are not broken. So if you the last test would be to test the individual windings of the commutator. And it shows resistance there, but as long as there's no resistance between the commutator and the chassis, it should be okay. Yep, and it's showing no resistance to the commutator and the chassis. So the coils in the chassis are not broken, and they're not short-circuited to the coils in the rotor are not short-circuited to the chassis or to each other, and same goes for the stator coils. So that means that this machine has good operational coils in its rotor and in its stator. The same thing goes with any motor. Here's a little closer look at what you got here. So you usually have wires that go to each one of the coil windings, and you want to just make sure that these windings are isolated from each other, and they are isolated from the chassis or the frame of the stator motor, because if there's a short to the stator, then the electricity will pass through the frame and not through the coils only, and the motor won't go anywhere, or the generator won't do anything. So you want to have the frame isolated from the coil. You want electricity to only go through the coils and nothing else, not the frame, not the metal in the frame, and not to each other either. You want them all isolated from each other and from the frame. And if they are, then the motor or generators is in perfectly operating order. And this machine here is an early 1900s 20 kilowatt generator from General Electric. I have this Variac transformer out of this casting machine that I'm going to use. It's going to send 120 to this transformer down here. This is going to step it up to 240, and this is connected to this rectifier over here, and that's going to turn it into DC to run the drive motor for this generator. And as it runs the generator, I'm going to throw the switch for the output coils, the output shunt coils, to then run this rotary transformer here. This rotary transformer takes about 34 volts of DC at 35 amps, which is quite a bit of amps for DC. And it's going to turn it into AC, and I'm going to run this bench grinder once I have the generator up to speed and the rotary converter energized and turned on. So here we go. Alright, now that it's up to speed, we'll go ahead and turn the switches for the rotary converter. Then the bench grinder. And that's how a complete power system works. And if I were to scrap this generator for copper, I could get maybe $500, $600 worth of scrap copper out of it. But since it's a functioning generator, it's probably worth anywhere from $6,000 to $8,000, maybe even $10,000, or even more, because it is a pre-World War I generator. So it actually might be worth more than that. It's very unique, and they don't make them anymore, and I've only been able to find one other one like this out there in the world on the internet, and it's a little bit bigger than this one, but there's only one other one that I can know of in the whole world, and I have this one. So there you go. AC to DC, DC to AC power system.